Okay, good morning, everyone.
Good morning, sir.
Good morning.
Good morning and Happy New Year also. So, today we will start the real integration. Actually, our main purpose is to solve the real integration only. But what we do, because real integration, if it is very difficult to solve, so what we do, our question from real space, we convert into complex space. And then again convert to real space. So this will be our methodology, okay, to solve such type of problems. So what are the real integration we are going to deal here? Number one, there are three types which question come in the exams. Number one type is you will find that integral in the form of 0 to 2 pi f cos theta sin theta, means function of cos theta sin theta will be there, and integration of that 0 to 2 pi, or sometime 0 to pi also will be asked, but that 0 to pi we can convert into 0 to 2 pi if function is even. Okay, if function is even, then our question, if question is like this, 0 to pi and function of cos theta sin theta is there, so then it can be converted to 0 to 2 pi only, 1 by 2 of that. So that will be similar, cos theta sin theta d theta. So this is one type of problem we will face. Second type of problems will be minus infinity to infinity fx dx. So this type of problem also we have to solve. Or third type can be, or not the third type, means if it is 0 to pi, integral 0 to pi fx dx. Again here also we will apply, if fx is even, then it can be converted to means this minus infinity to infinity fx dx, that will be converted to 1 by 2 of 0 to infinity fx dx. Okay, so like this we can have always conversion, there is no issue. Or actually we will develop a formula which will be directly for this only. Okay, so you may not need this step, but if fx is odd, so then definitely you can take I equal to minus infinity to infinity fx dx, that will be directly 0. That is important thing. If your function is odd and you are having the integration of this, so that will be 0. Understood? That you can use directly. So these are some property, and these are the real integration we will utilize here. Okay, so note down it. Or you can say it third type only. Three type of problem you will face. Sorry. Actually, it will be twice. minus infinity to infinity fx dx will be twice of that. Means if this I want to convert there, na, that will be opposite to that. So 0 to infinity fx dx will be half of this much. Or you can say it like this. If fx is even, so then 0 to infinity will be converted to half of minus infinity to infinity. Because we will develop a formula which will be working on minus infinity to infinity. So this term also, if fx is even, so then this will be converted to minus infinity to infinity, and if fx is odd, so for that, but that is for this one, okay? So it will be 1 by 2 of this much. Then you can do. Okay? Done?
Yes, sir.
So you have to learn in complex now, you have to practice it once again, because then you can solve all type of problem of the complex. So I am taking the first case. In first case, the question is of type integral 0 to 2 pi f cos theta sin theta d theta. Okay, this type of problem will be there, and you have to find out the solution for that. So what we will do here, method, what method we will apply? Method we will use by substitution. By substitution of theta value and converting into or you can say converting the real space, because this was your real space. This is your real space question. Understood? No imaginary value is there. So by substitution of theta value and converting real space into complex space. Okay, we solve the problem. So this is our main motto, and the answer will be again in answer will be found in real space. The same thing we will do here. Now in complex space, in bracket you can write z. So z value means our function should be converted to z or fz. Understood? Z should be there. So then it will be a complex space, and real space is your theta space. Okay, so we have to make a relation between them. So what we have to do, we know that z is equal to r e to the power I theta. You know it. Okay, z equal to r e to the power I theta. This implies that origin is 0. Actually, we know the universal formula. If it is z minus z0 is equal to r e to the power I theta, this type of thing is there. So then your origin will be z0. Origin will be z0 and radius will be r. So this type of information you will have from this equation. Now for z equal to r e to the power I theta, your origin is 0. So origin is 0 and radius is r. And that if I take radius equal to r equal to 1, so then this will become z equal to e to the power I theta. So this will be my this will be used for transformation. So z equal to e to the power I theta gives the relation between theta and z. Understood? So that we want. So then this will give me the unit circle. So it is valid for unit circle. Valid for unit circle with origin at 0. So this much you know. So this is important thing. We will use this much this transformation for solving such type of problem. Okay, note down this. Because here if you want to know the radius now, so radius we can find out by mod z. So mod z of this will also be equal to 1. Because e to the power I theta is cos I theta plus I sin theta, and from there you can find plus this mod z.
Sir,
Yes.
sir, the exponential iota theta will not be included in radius portion because, sir, mod z minus z naught is equal to radius.
No, you can do it like this, no? No, I'm telling you just mod z from here. What is mod z value? E to the power I theta, you can write cos theta plus I sin theta. So what will be mod of e to the power I theta or mod of z? That will be under root of cos square theta plus sin square theta. So that will be 1, na? Just I'm telling you, if you want to find out mod of z, that is also here 1. And yes, r we have taken already 1. R we have taken already 1. Okay. Radius is also 1. Mod z is also 1. And because just we are developing the basics. If sometime it comes, what is the value of mod z, so that you can directly take 1. Okay. So this mod z equal to 1 is from here. Hello?
Hello.
Yes.
Yes, sir. Sir, the condition for Z not equal to 0, sir. Please explain, sir. Like R equal to 1 is unknown, sir. But for Z not equal to 0, sir, this valid for only unit circle with origin fluid lines.
Okay. First you note down this.
Yes, sir.
This is done.
Done, sir.
Okay. Actually, we have a universal equation. Universal equation is like that. Z minus Z0 will be R e to the power I theta. In that, this Z0 always give you the origin, point of origin. So this is the origin point. And this R, it gives you the radius. Okay, in polar coordinate if you are saying. So here if you take Z0 equal to 0, okay, so 0 will be your origin. Only this much I told you. Okay, so this is your origin point. So it means your circle will be like this. This is the imaginary part, this is the real part, this is your origin. So origin will be 0, and because R we have taken here 1, so it is a unit circle. And unit circle means it will cut here at I, it will cut here at minus I, it will cut here at plus 1, here minus 1. So this is the meaning of that. So this is known as unit circle. And in such type of question, we will always take directly z equal to e to the power I theta. So this is our transformation point. This is the transformation we will do to solve such type of problem. And always we take a unit circle. Always we take a unit circle, because this everything is valid only for unit circle. So this is transformation to solve the problems. Okay, this is our transformation. And here what we take, because our function is like this, I equal to integral f d theta. So d theta also we know. So this is our equation number 1, which is we are using for transformation. So from 1, differentiate that, dz will be equal to e to the power I theta into d theta into I also. That will be the answer. But because I want d theta, so d theta will be dz 1 upon I divided by e to the power I theta. This e to the power I theta, what I can write? Z. So it will become dz upon zi. So this d theta can be replaced. D theta can be replaced dz upon iz. So these are the two equations. This is equation number 1. This is equation number 2. So these are the two equations I will utilize to for conversion. Understood? For conversion of real thing into imaginary thing. Note down this.
Done, sir.
Okay. So now formula, one more thing you have to remember. Third thing is that if your integral is 0 to 2 pi, okay, or only integral I will tell. So this integral can be converted to closed contour, because 0 to 2 pi means it is a circle starting from here, just take a full round and come to here. So that will be 0 to 2 pi. And this closed circle is also telling you the same thing, that start from here and come to here. So these are always equivalent. Understood? So always 0 to 2 pi can be converted to closed integral. So this also you must remember. So this is just silly things, but I am telling you, we can use whatever we require. Okay. So real problem can be converted to complex space by the formula so which formula we can use, because our real problem was 0 to 2 pi f cos theta sin theta d theta. Now I will convert this problem into complex form. This is the real form, real space, and here I am using complex space. So here closed integral I will convert. This integral I will convert to closed integral, and my function will become fz. In place of f cos theta sin theta, it will become fz, and d theta will be written as dz upon iz. So this will be the our actual formula for conversion. Okay, so this formula you have to remember, and this is your complex form or complex space. And in complex space, we can use the Cauchy integral formula. Now we can use Cauchy integral formula For that, integral will be 2 pi I into summation of residue, and residue will be find out from fz. Residue will be find out from fz. Simple. So this only this much you have to do. Now some more relation we have to find out. Just they are just our need. What we will write to suppose 1 upon z is there, so that will be replacement of e to the power minus I theta. This much you know, okay, because z is e to the power I theta, so 1 upon z will be e to the power minus I theta. Similarly, if I want to convert suppose cos theta into z terms, so how I can write? Cos theta is nothing but e to the power I theta plus e to the power minus I theta and divide by 2. So what I can do, e to the power I theta can be written as z, e to the power minus I theta can be written as 1 by z and divided by 2. So 1 by 2 common, it will become z square plus 1 by z. Okay? Or you simplify we can do afterward, because this thing will be adjusted with numerator or denominator like this, but up to here we can remember it. Just simple formula that cos theta can be converted to 1 upon z plus 1 upon z, and similarly sin theta also can be converted to 1 upon 2i, because iota will be there with 2. 1 upon 2i e to the power z minus 1 upon z. So this is formula for sin theta, this is formula for cos theta. So these are also the conversion formula. We can directly use them. Okay, so note down this also. Okay, so let us solve some problem. Integral 0 to 2 pi Ramo, actually, as per our syllabus now, the question will be like this only, that our origin is z0 equal to 0 and radius is 1 as per our syllabus. But for different radius and different point also we can make the problem. Okay, there is no issue. But because this is the learning thing, in research work it can be anything, but for learning thing only. And in pure mathematics also, na, in MSc mathematics or mathematics, questions are for those also, for different radius and different origin also, because they are pure math. But we are just a small portion of this, so our syllabus is up to there. So that's why we will read that. So I 0 to 2 pi, this is the question. Sin theta d theta, we have to show what is that. See, because sin theta is a odd function, so 0 to 2 pi odd function will always be 0, that I know. But by I want to use this method to find out the just to go through what is the method So first we will convert that into complex form. Okay. Put sin theta equal to 1 upon 2 pi 2i z minus 1 upon z. And d theta you have to apply dz upon iz. So this will be our method how to convert this into complex form. So integral will be closed integral 1 upon 2i z minus 1 upon z dz upon iz. Okay, that will be my conversion. So now what can be further? We can simplify it. Closed integral this I, it will become I square will become minus, and 1 by 2 already there, into here what, okay, this z now you can divide it, it will become 1, it will become 1 minus z square dz. Okay, so this is my complete thing. Now here what is fz? Fz will be this whole, this will be minus 1 by 2 and plus 1 by 2 z square. This is your fz. In fz, because this is a Lorentz series, in fz the coefficient of 1 by z, because Lorentz series about z equal to 0. So for z equal to 0, so coefficient of 1 by z will be your residue, and that is equal to 0. So integral will be 2 pi I into residue equal to 0. So answer is 0. And that we already know because this is a odd function. And for odd function, 0 to 2 pi, always answer is 0. So this is verified from this. Note down this. So this is the method how we apply. Okay, next question. Zero 2 pi d theta upon under root 2 minus cos theta. This is a question. So this integral you have to find. Again, do the same thing. Put cos theta equal to 1 by 2 z minus, sorry, z plus 1 upon z. And d theta equal to dz upon iz. So this will be, so this integral will be converted to closed integral your 1 upon under root 2 minus 1 by 2 z plus 1 upon z into dz upon iz. Okay, so this iz again will be multiplied here, so it will become, I will be coming out, so it will be closed integral c, what I am taking outside, so z will be multiplied here, so it will become 1 upon root 2 z minus 2 root 2, because 2 also I will take LCM. Understood? And that 2 I will take here. So 2 root 2 Z minus Z square and minus 1. Okay, so like this it will become. Now here because Z square should be the first term, so again I have to take minus common here. So it will become minus 2 upon I close integral 1 by, sorry, dz is also there, 1 upon I Z square minus 2 root 2 Z and plus 1 and dz. So this is my complete thing now. So from here we can take our fz is minus 2 by I and this much, that will be our fz. So from that fz I have to find out the residue. Here fz is minus 2 upon I into 1 upon Z square minus 2 root 2 Z and plus 1. So to get the residue, first I need to find out the poles. Okay. So to get poles, just put the denominator equal to 0. So your denominator is Z square minus 2 root 2 Z plus 1 equal to 0. So you can use the Sridharacharya formula. Okay. So first complete this page, note down it. This is a quadratic equation, and a quadratic equation, actually we want to convert this equation in the form of Z, because this is a quadratic equation, it will have two roots. Suppose alpha beta are two roots, so then this equation will be converted to Z minus alpha into Z minus beta equal to 0. But root I have to find from this equation, and for that I can utilize Sridharacharya formula. Note down this first.
Done, sir.
Okay. So your Z will be minus B. B is here already minus, so minus minus will become plus. Minus B plus minus under root B square minus 4AC divided by 2A. That formula I'm using. So B is already minus, so minus minus plus 2 root 2 plus minus under root B square is 2 to the 4 into 2, 8 minus 4AC. 4A is also 1, C is also 1. And divided by 2A, 2 into 1. So answer will be 2 root 2 plus minus 8 minus 4 means that is also 2 and divided by 2. So answer is under root 2 plus minus 1. Okay. So alpha will be, means one root will be root 2 plus 1 root, or you can say pole also. These are two poles, alpha beta. Beta will be root 2 minus 1. Okay, so these are two poles. Now which pole is outside, which pole is inside, that also we have to see. What is our contour here? I told you for this type of question in our syllabus, it is a unit circle. Real axis, imaginary axis, this is I minus I plus 1 minus 1. Now see, root 2 plus 1, that root 2 already 1.4 and plus 1 2.4, that is outside. So this is your alpha, and beta is root 2 minus 1, so that will be somewhere here, that is beta. So beta is inside This one is inside pole and this one is outside pole. So for outside pole, we will not calculate the residue, only inside pole will be considered. Okay, now residue for inside pole beta equal to √2 minus 1. So for this you have to find out. Okay, so your FZ will be now, FZ you can write where it was FZ. This was your FZ. So FZ can be written in simple form. I am writing it first. Minus 2 upon I into minus 2 upon I into 1 upon this much, and this much because I want to write in term of pole, that will be Z minus alpha into Z plus alpha. 1 upon into, sorry, Z minus beta, Z minus alpha. In this form I will write it. So this is my FZ. So for to find out the pole, I will use the method of simple pole. Okay. Limit Z tending to beta, Z minus beta into FZ. FZ is minus 2 upon I, 1 upon Z minus alpha, Z minus beta. So Z minus beta to beta cancel. So answer left is minus 2 upon I into 1 upon Z minus alpha. Sorry, Z I am writing beta, so it will be beta minus alpha. So what is the value of beta minus alpha? Beta minus alpha. Beta minus alpha will be √2 will be cancelled. Answer is minus 2. So minus 2 to minus 2 cancel. So answer will be 1 upon I. Note down up to here.
Done, sir.
Okay, so residue, only one residue we required inside residue. So integral will be 2 pi I into residue. 2 pi I into residue is 1 upon I. So answer will be 2 pi. So our integral 0 to 2 pi d theta upon under √2 minus cos theta will be equal to 2 pi. So this is the final answer. Understood? So this, by this method, you can find out it easily. Okay. So for such type of question now, when suppose here this is like A and here one coefficient is B, if such type of problem is coming and this is for a full circle, 0 to 2 pi means full circle. Okay. If this type of problem comes in the exam, so we have one quick formula also. Directly you apply this A and B value in that and you can find out the answer. Okay. So that formula will not be found in any book. Okay. So that has been generated by someone just for teaching purpose. Understood? So that formula is quick formula. and that is working. Okay, it will save our time in the exams. Integral, if integral is of the type 0 to 2 pi, you have to mind it that only for this type of problem you can apply it quickly, and many times this type of problem comes because in the exam very less time we have for such problem, and it is time consuming. It is same form is 0 to 2 pi d theta upon a minus b cos theta. So here whatever is there, that is considered as a, minus sign is there, then coefficient of cos theta is b. Okay, if such type of problem come, directly you can use 2 pi by under root a square minus b square. So this is the formula, direct formula to find out the answer. Okay, so this you have to remember. And here, because a square minus b square is there, so a must be greater than b. That is also you have to ensure. Suppose here, because under root 2 is more than 1. Understood? So it is satisfying the same condition. So if I apply the same formula here, so I will be equal to 2 pi by under root a square. A square is 2 minus b square. B is already 1. So answer is 2 pi. So it is verified. Understood? So like this we can solve the problem. Note down this. Yes.
Is it only valid for a minus b cos theta term?
Yes, only for this.
Okay, sir.
Rest all you have to apply the method. Actually, as per books, it is also not there. But someone has made this formula and they have taught it. Okay, so that's why we can use it, and it is valid. If it is in this format, so then it is always valid. You can use it. So this is just a quick formula type shortcut method. Okay, so there is a homework for you, and this problem is NET 2019. It is 5 marks question. So this is homework for you. Full method you have to use. Solve by, because it will give you the practice. Solve by full method. Question is, find integral 0 to 2 pi d theta divided by 5 minus 4 cos theta. So this was the question. Sorry, it is 0 to pi. Okay, options are pi by 3 minus pi by 3, 2 pi by 3 minus 2 pi by 3. See, if you do the mistake in minus, then options are always available. Understood? So you will get negative marks. So that's why you have to be very carefully, and you have to develop accuracy inside yourself. So once you are preparing for NET or this, actually your accuracy will be increased. Okay, so accuracy, then it will be set in your mind. So it is used in your whole life. Whenever you do some work, so accuracy will be developed automatically. So that's why this learning is not only for these exams. It is for your whole life. Your skill will be good. You will do the work with accuracy. and your mind will be set like that. Understood? So these are very good things. So solution for this, actually I can use it directly because I have given you one trick, so that I can use, but that is valid only for 0 to 2 pi, but it is given 0 to pi. But again, if I check whether it is a even function or odd function, cos theta is there, so it is a even function. So I can use integral 0 to pi d theta upon phi minus cos theta can be converted to 1 by 2 of 0 to 2 pi d theta upon phi minus 4 cos theta. Here a is greater than b. This condition is already applied because a is 5, b is 4, 5 is greater than 4. So I am using the direct formula. So my direct formula is 2 pi by under root a square minus b square. A square is 25, b square is 16. So answer is 2 pi by 3. Understood? But 1 by 2 is also there. So answer is pi by 3. Now you understood. If someone is ignoring this also, in place of taking 2 pi, he is taking directly from 1 pi. So he will not use this 1 upon 2. So then he will give the answer 2 pi by 3. And that is also available in this. Understood? So wherever the student make mistake, so that mistake is also available in option. And then he will not rethink the question. That is the problem. So that's why maintain the accuracy, note down it. And your homework is to solve it by full method, and you should get the answer. Then you will have a good practice. Note down this. Okay. So I will solve one more problem. That is a lengthy problem, so that you can learn it well. And after that, I will jump to another type of question. If here they give 0 to 2 pi, sorry, 0 to pi, so then you can make it 1 by 2 of 0 to 2 pi. But it is given 0 to 2 pi here in this question. So here we can simplify it. Sin square theta we can convert into cos theta term. Understood? So that we can do. And one more thing we can do. In numerator, we can use suppose cos theta is there, so that can be used as real part of e to the power I theta. And if sin theta is there, we can use imaginary part of e to the power I theta. So then problem can be solved easily. Understood? In a numerator only, but not in denominator. In denominator we never change, but never use for denominator. Means what I mean to say, suppose this is like 1 upon cos theta, so you want to use it like this. No, it can never be. Only this is allowed. If it is in numerator, then you can use in place of cos theta real part of e to the power I theta, sin theta imaginary part of e to the power I theta. Okay. So now this sin square theta, first of all, I can convert it into cos 2 theta. Okay. So I can write it like this: integral 0 to 2 pi 1 minus cos 2 theta divided by phi minus 4 cos theta d theta. Okay. Now this complete thing I can write real part of that. It will be 0 to 2 pi, or real part of, in place of cos theta I will use e to the power. So it will become 1 minus e to the power I 2 theta divided by phi minus 4 cos theta d theta. So this is how we can convert into easy form. Now we can do the, because this is the real space up to now. It is the real space. So next what is my step? I have to convert into complex space. So to convert that, put cos theta equal to 1 by 2 z plus 1 by z. Okay. And e to the power I theta I can replace by z. So e to the power 2 I theta will be replaced by z square, because I have this term. Now one more thing, d theta will be written as dz upon iz. So this much conversion I will do in this equation, then real space will be converted to complex space. Okay, so note down it.
Done. Sir.
Okay. So my integral will be real part of 0 to, so 0 to 2 pi I will convert as closed integral over the contour C, and contour C is my unit circle, because for this type of problem we take it unit circle. Okay, so it will be 1 minus z square divided by phi minus 4 into 1 by 2 into z plus 1 by z into dz upon iz. Now simplify it. So 2 to 2. Okay. So this z will be multiplied in whole equation. So what it will become? Real part of closed integral 1 minus z square divided by 5z minus twice of z square. I will take here, no role of I here. So twice, minus of twice z, and z multiplied by z square. Z to z cancel and minus 2. This is the equation. But I want z square in first term. That replacement I have to do. And so it will be real part of 1 upon I. So for that, what I can do? It will become this upper portion also I can do z square minus 1. Okay. So that minus will be adjusted. Then it will become z square minus 1. It will become 2z square minus 5z and plus 2. Now I told you one day that this coefficient always I want 1. I have to make it 1 here only. Then only I have to find out the poles. Understood? Otherwise your question will be wrong. You will get a wrong answer. You are doing the same method, means this complete denominator if you put equal to 0 and you find out the pole, so that method will be wrong. Always make it coefficient 1. So here only you have to take it common. So it will become real part of 1 upon 2i. Integral z square minus 1 divided by z square minus 5 by 2z and plus 1. Okay, so this is your denominator from where we want to get the pole. So to get poles, put denominator equal to 0, so that will be put as equal to 0. Z square minus 5 by 2z plus 1 equal to 0. So from here again you can use Sridharacharya formula. So z will be minus b, minus minus will become plus, and plus minus under root b square minus 4ac means 25 by 4 minus 4 and divide by 2a. A is 1. So by this method you can find. We can more simplify it. So two poles are there, plus 5 by 2 plus minus under root. This will be 25 minus 16 means 9 by 4. 9 by 4 will be 3 by 2. Okay, and divide by 2 also there. So there are two poles. First pole will be 5 by 2 plus 3 by 2. 8 by 4 means 4 and divide by 2, 2. So answer is 2. And 5 minus 3, 2 by 2 is 1. Answer is 1 by 2. So these are the two poles. Okay. And this now you can check. This is 1, this is minus 1. This 2 will be here, so that is outside that. So this pole is outside and this pole is inside. This pole is here, 1 by 2. So these are the two poles. So for inside pole only we will find out the residue. So first note down up to here. Carefully you have to solve such type of problem. So residue of Fz we have to find now.
That's it.
Okay. So residue at z equal to 1 by 2, that you have to find. Residue will be limit z tend to 1 by 2 into z minus half into fz. For that fz, numerator will be as such and denominator part will be z minus half, because this is one pole, into z plus 2. Sorry, z minus 2. So these are two poles. So z minus half to z minus half cancel. So that will be limit or you put the direct value, z square minus 1 means 1 by 4 minus 1 divided by half minus 2. So what will be answer? It will be minus 3 by 4 divided by, it will be 4 minus 3 by 2, no? So answer will be 1 by 2. So this is your residue. One by, this is 3 by 4, this is minus 2 to the 4 minus 3 by 2. Okay, 2 will go up to 2 by 4. Okay, you can use it. So integral is what? Real part of 1 upon 2i. 1 upon 2i into, and what is the integral as per residue? 2 pi I into residue. Residue is 1 by 2. So this 2i to 2i cancel. So real part of pi by 2 is pi by 2 only. Okay. So 4i minus 2i. Come here. Actually, here we have done a small mistake. When we are converting this sine square theta, na, you can make it 2 sine square theta. That 2 sine square theta is 1 minus cos 2 theta. Understood? To make that 1 by 2, I have to add here. And that 1 by 2 will be everywhere. So 1 by 2 will also be here. It will be 2i. It will become 4i. It will be 4i. So answer is pi by 4. So this is the correct answer. Okay, note down it. So like this full method I have given to you, and only up to this much complex the question can be, and you can solve it. If it is of the first form, so then direct quick formula you can use, and if it is this much, so this much you have to do. Okay, note down it.
Sir, the final answer is the real number. We did not apply the real part, right? Already it's real. Final answer.
Yes, no need to convert. Means answer will be in real. Whether it come automatically or we have to convert. If suppose something was there, so real part only we have to take. Ultimately we are coming back to real space. That's it.
So that means the answer will be same even if it was sine, because sine will be imaginary. No, it will be 0, right? If it is imaginary.
Imaginary
We have to take
No, it will not be. Yeah. Actually, imaginary value is not there. Automatically, it is coming to real value. But sometimes it can come. So from that, you can choose real portion.
Yes, sir.
Just method we are learning. If in some question, some imaginary portion also come, that we will leave completely. Okay. And if this conversion was for sine theta, so then we have to take imaginary part. Our answer will be in imaginary. Out of that, you have to take only imaginary coefficient. That will be answer. Okay. Okay. So now this type of question also will be there in exam. Now I will use one more type. Second type we can take. These are also real integral. Minus infinity to infinity fx dx. Okay. Like integral. So integral of this type because these are the real space. So here see how will be my conversion and how I have to solve the problems. See here. These are the points. It is coming. This is a line. This is coming from minus infinity to infinity. Okay. So this is my real space. This is the origin. Actually, this is my real integral. This is your real space integral. And what I told you, you have to convert it into complex space. So how I can convert into complex space? In complex space, I need some contour. I need some contour. So you can think it like that this is a bar, which is a very long bar going to minus infinity and infinity. You can shrink it. Because I want to convert it into a, I want to convert this into a contour. So how I can make it? That the longer part which are infinity side, I will shrink it. So that portion, this portion will be utilized to make it contour. So shrink it, then it will become a contour. This much I am using, but rest all part which are from minus infinity to infinity, that is utilized to make it contour. Understood? But because direction was same, so direction of this integration was minus infinity to infinity plus infinity. So direction I am taking same, and this value, because this is a fixed value, suppose this value is minus r, this value is plus r, up to here it is a fixed value. And whatever the extra portion was there of this material load, that I am using to make it contour. So you have to shrink it, and it has become now contour like this. Okay. So here, this is complete contour. C dash is complete contour, but from here to here, if this portion I am only seeing, that is a C contour, and this is a line. Minus R to R is a line, and from here to here it is a open contour. It is made of, this C dash is made of two things, minus R to R line and then a contour C. Okay. So what I can write? So here C is just a semicircle. You can write this C dash is nothing but your semicircle contour C, and plus this line minus R to R. This is the contour, and this C contour is this one. Okay, and this C dash is this complete contour. So this complete contour I am converting to this C and this minus R to R line. Okay, now, so now for this contour, I can utilize the here we can use Cauchy integral formula. And what is that? For closed contour C, sorry, C dash is complete closed contour. Fz dz will be equal to 2 pi I summation R. Okay. And this your R will be taken from Fz. Residue is calculated from Fz. Okay, up to here you understood. Just I have done what I have done. My real space integral has been converted to complex space integral, and in the complex like this by this method, and in the complex space method I can utilize the Cauchy integral formula. Only up to this much we have learned. So note down it first.
Done, sir.
So this formulation of this method just you have to practice 2 times, otherwise you will forget what we have done. If any doubt is there, you can ask. So here this line is the real line, real axis, and again for real axis z equals to x plus iy, because I is not there, so that is equal to z. So I can have z equal to x for this line for real axis. Okay. So now this fz, because this c dash is c and minus r to r, there are 2 things. So this fz dz I can convert into 2 part, because c dash is equal to c plus minus r to r line. So I can convert this part into minus r to r line, and for that my function fz will be working as fx. For that line my function will be fx dx. So this part is over, and plus integral, this is now open contour. You can see here this c contour is the open contour. I am talking from here to here, not the line, not line. It is the open contour. So c is the open contour, and c dash is the closed contour. I am talking about closed contour. Closed contour means it will include the line also. Okay, so this is my c. It is not closed. Don't place the circle here, and it is in fz dz. So this left hand side I have break like this. That will be equal to 2 pi I into summation of residue. Understood? Very easy. Now again I have to convert. Again I have to convert this part. This was the complex part. I have to convert into real part. Convert into real part by extending. Here you have shrink it. Now you can expand it by expanding to infinity. So both side by expanding r to infinity, your r negative side also, positive side also, again you revert it back. So what it will convert now? Again it will become the real line. Again it will go from minus infinity to plus infinity. Now where this portion have gone, this will become to 0. Understood? This portion which I am talking about, C open contour, it will again become 0 because I have converted it back. So this material have gone from here. It means this will be converted to 0. So my equation is left. Now in place of r to r, I will use, because I have expanded, r has been converted to infinity. So it will become minus infinity to infinity, fx dx will be equal to 2 pi I into summation of residue. So this is my final formula. So directly this minus infinity to infinity fx dx also will be equal to 2 pi I summation r. But this residue I have to find from complex portion only. This you must know. So that's why I have to convert my function fx dx into fz dz. R to be find out from fz means complex function. Fz is complex function. So like this, my question again converted to, so it has become now real space. So like this I have to do here, and this was given by Jordan Lima. Formula. So separately also we can see it. So what is the Jordan Lima formula? Limit, if your r is tending to infinity, so then for open contour, this is C is open contour, fz dz will be going to 0, where C is your just a half circle. R e to the power pi theta. Okay, so this was the Jordan Lima formula, and it is applied for half circle also. Our case it is half circle only, but it is for full circle also, Jordan Lima formula. Okay, but if your r is tending to infinity, for that this function fz dz is equal to 0, and that we have taken from here, and then we can understood from it here also. Note down this. So directly now we will use this star formula. But how it came? So this was the method how it came to understand that.
Done, sir.
Okay, so now we will understand it more with the numerical also, but some more basic you have to learn. All poles on the axis, and or you can say, because see here, because this fz is defined only for contour now. This fz is defined for this contour. Understood? So from here, this fz, whatever the pole comes, either they can be on this real axis or they can be inside this contour. There are two options available. If they are inside the contour, so then I can use 2 pi I summation r. If they are on the axis, so then I can use pi I into summation r. This also you must remember. And the poles which are either on the axis or inside the contour, only those will be considered. Rest which are outside, they will not be considered. This much also you know. Okay, and you already know it. So all the poles on the real axis or imaginary axis also can be there, no problem. So all the poles on the axis or inside the contour. Contour means just upper half of the upper half. You can use upper half circle in on the axis or upper half. Upper half circle, because only upper half circle is our contour. Will be included in residue calculation. Okay, and for that also, because two type of poles are there, so for them which are on the real axis, these are the poles on real axis. If poles are on real axis, so then you have to take minus infinity to infinity fx dx equals to pi I into summation r. If your poles are above the real axis, inside the contour, so then you have to take this integral 2 pi I summation r. So these are the two methods. Note down this, then we will solve the problems.
Sir,
Yes.
so the upper half circle implies that all poles on the upper part, right? Because the radius is going to infinity.
Yes. No. Oh. Residue. For residue, we have to consider this is true. For residue, we have to consider this is true. Here, radius is not going to be infinity. Up to here it is. Means radius is 1. Our contour is existing in the complex part. It is not infinity. R is some limit.
Yes, sir.
This R is different. This is the residue. This I just taken 2 points, minus R plus R. Okay, so let us take one question. Find integral minus infinity to infinity but here now actually here if it is 2 3 4 5 6 whether it is bigger now, so that bigger also you have to consider, because this r ultimately this r is very large. So all the value whatever it comes, whether if it is on real axis, so it can be 1000 also, that also you have to consider. On the real axis all the value you have to consider, above that also you have to consider, that I mean to say. Understood? Because above that value, suppose some 5i is there, because my contour is not fixed here, contour is not fixed, it is imaginary here. So that always can be think bigger, because this ultimately this r tends to infinity at final stage, so r can be taken bigger value. So for that bigger value my contour also will be bigger, so in that 5i also will be included. So that's why the statement is given like that. If it is above the real axis, okay, you actually all the point will be inside only, just above the real axis also is sufficient. Above the real axis whatever the point is there, they are always inside the contour, that is considered here. And on the real axis, then this formula will be there. On the real axis it can be 5 10 11 whatever, all will be on the real axis, so you have to use the formula. And above the real axis all will be inside the contour, but below the real axis all will be outside the contour. So this is our methodology here. Okay, so this line is sufficient. Above the real axis it is sufficient, because all points above the real axis plus 5i plus 10i plus 11i like that all will be inside the contour only, because our contour can be bigger. Whatever you think, it can be more bigger. Whatever is your value, it can be more than that bigger. Understood? Like this way you have to think. So this is your question, sin x by x dx. For that you have to find out value. So what I told you, you have to convert this real function into because see, why I need the fz? Just to find out the residue. Otherwise formula I know, that formula directly I will use. This whole process I will not repeat again and again. This final formula I use, and residue I will find out from fz. So first you find out fz, then find out the residue, then use this formula. So these are the three things. So convert real function into fz function. This is our first motto. Okay, so here suitable fz function will be fz equal to imaginary part of because this see actually okay, I will write it completely, don't be confused. Suitable fz function, whatever the x is there, in place of that write z, so it will be sin z by z. And what I told, that sin z can be converted to e to the power iz. So it will be imaginary part of e to the power iz divided by z. So this is my function here. Okay. So from here you can find out residue. To find residue, I have to find pole, and pole will be z equal to 0. To get pole, put denominator equal to 0. It means z equal to 0. So this is our pole. So residue at z equal to 0 we have to find. So we can use the direct formula. Limit z tend to 0 z into fz means it will be imaginary part of limit z tend to 0 into z into e to the power iz divided by z. Z to z cancel, put z equal to 0. So that answer will be 1 only. Understood? Or you can say your fz is this much now, imaginary part of this. So this imaginary part I will find out from because to find out the residue I can use it directly. And your answer, the integral will be imaginary part of, or you do it one thing, from here only you can convert this equation. Minus infinity to infinity, this is imaginary part of sine x you can convert e to the power ix divided by x and dx. Okay, so here this function I am taking just fz. So fz will be here, direct you can take, just x you can convert into z. So it will be e to the power z by z. Like this you can do. And from here just I am finding out the residue. So residue will be 1. So integral will be imaginary part, because this is the imaginary part of 2 pi I into residue. That formula you can apply now. Imaginary part of 2 pi I into 1. So 2 pi I into 1, imaginary part of that is only 2 pi. So that will be the integral. Sorry. Our actually pole is at pole z equal to 0. That also we have to check now. For this kind of thing, pole is at the real axis. This is our pole z equal to 0, and it is at real axis. So for the real axis, what I need to take? In place of 2 pi I need to take pi I. So this is your answer, pi. Understood? Note down it.
Done, sir.
Okay. So from this also one net question I will take. NET 2019. Find integral sine 2x by x cube dx. So this was the problem, and this I can convert as imaginary part of, because I told you if in numerator sine or cos is there, you can convert into e to the power. So that will be easy to solve. So it will become imaginary part of e to the power I into 2x divided by x cube dx. This is my problem now. Okay, but it is not given in the question. This I have converted. So from here, suitable, because I need to find the residue now. So here suitable fz function will be just you have to convert x into z, then you will get the suitable fz. Fz will be e to the power I into 2z divided by z cube. Now from here you have to find residue. There are two methods. Either you expand this, then divide by z cube, then find the value of coefficient, or here z equal to 0 is the pole of third order. You differentiate it 2 times and then you can find. Okay. So two methods are there. Suppose here z equal to 0 is pole of order 3. So that method also you can apply, or simply you just find the Lorentz series by using the method e to the power 2iz. You can write 1 plus, you can open exponential, that is also easy, 1 plus I into 2z by factorial 1 plus I into 2z whole square divided by factorial 2 plus dot 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 and divide by z cube. Okay. So residue will be equal to b1 means coefficient of 1 by z. And what is the 1 by z here? From here you will get 1 by z cube. From here you will get 1 by z square. From here you will get, it is z square by z cube. From here you will get 1 by z. So what is the coefficient of this? That will be the answer. So it will be I square is -1, 2 square is 4, divided by 2. So that is 2. So -2 is the answer. Understood? So residue will be this much. Note down this. But that is, you have to mind what is your pole. Z equal to 0 is the pole, and pole is at real axis. So formula what you have to use? Pi I into R. That will be the formula. Done?
Yes, sir.
So integral will be, I already told you that it is the imaginary part of pi I into residue. Means imaginary part of pi I into -2. So answer will be -2 pi. Okay. So this type of question you have to practice. Otherwise, little bit if suppose you are taking here 2 pi I into residue that you have mug up, so you will make a mistake. Okay. So I can take one more question. Little bit difficult I am taking. Such type of question will not come in exam, but it is for practice, so that you understand the method easily. Question is, find integral minus infinity to infinity dx upon 1 plus x to the power 4. Okay. And I know that my contour is this much only, what I have discussed. Minus r to r, imaginary and real axis. Okay. So to get the poles, I already discussed this thing. So first of all, we have to find what is the suitable function. Fz will be 1 upon 1 plus z to the power 4. You have to get the poles. To get poles, put 1 plus z to the power 4 equal to 0, z to the power 4 equal to minus 1. We have already discussed it. This minus 1 can be written as e to the power I 2n plus 1 pi. Okay. So z will be e to the power I 2n plus 1 pi by 4. Understood? Here you can put n equal to 0, 1, 2, 3 because this is having 4 roots. So 4 poles will be there. So by placing n equal to 0, z0 will be e to the power I pi by 4. Means this is the 45 degree. So answer will be 1 by root 2 cos 45 degree plus I sin 45 degree. I 1 by root 2. Next will be by putting n equal to 1 e to the power I 3 pi by 4. Answer will be in 1 by root 2 only. Just you have to check the quadrants. For which quadrant cos is positive. So this will be in second quadrant. So that's why in second quadrant sine is positive, cos is negative. So answer will be 1 by root 2 minus 1 by root 2 plus I 1 by root 2. This is first, second, third, fourth. Like this quadrant you have to check, and angle you have to see from here, this angle. Now Z2 will be e to the power I 5 pi by 4. So 5 pi by 4 will be in this quadrant, third quadrant. So in third quadrant both are negative. And Z3 pole will be e to the power I 7 pi by 4. This already I have done. That will be in fourth quadrant. Answer will be cos will be plus here and sine will be minus here. Okay. Now we have to check that which one is on the real axis, which one is upper real axis. This is minus r to r. This is real axis. So see, this is 1 by root 2 and plus I something. So you go this side and you go this side. This will be your Z0. Again, Z1 minus 1 by root 2 and go this side. This will be your Z1. If you check the Z2, so Z2 is 1 by root 2 minus 1 by root 2 and minus I by root 2. So that will be this one, Z2, and it similarly Z3 will be there. So these two are outside. These two are outside, so we will leave them. Okay. So Z2 and Z3 are outside poles. So we will leave them, and these are inside pole. But they are inside the contour. Inside the contour, so we will use the 2 pi I formula. This also you have to remember. Okay, so note down. You have done it. Note down this first.
Sir, go little back, sir. Scroll up.
Okay. Okay.
Yes, sir. Done, sir. Sir, next page.
Okay. Done.
Yes, sir.
Okay, so we can find out the residue. Here Fz is 1 upon this much, or 1 plus z to the power 4. Okay, this is the Fz, and this you can do by this method, phi z by psi dash z. This is psi z, this is sorry, this is psi z, this is phi z. Okay, so you can do it by phi z by psi dash z method. Okay, residue by phi z by psi dash z method. So this method we will apply here for, but here okay, for pole, because 2 pole are inside, so 4 pole z0 I am using it, so that will be limit z tending to z0 phi z by psi dash z. That will be my residue R0. So answer will be limit z tend to z0, phi z is same 1, psi dash z will be 3z to the power, sorry, 4z to the power 3. In that you put z0, so that will become 1 upon 4 z0 cube. Now put the value of z0. Z0 value is 1 by root 2 plus I 1 by root 2, or you can use this value, that will be better to use, e to the power I pi by 4. Okay, so R0 will be 1 by 4 z0 to the power minus 3 and Z0 value is e to the power I pi by 4. So it will be 1 by 4 e to the power minus 3 I pi by 4. Or pi I by 4, whatever you want. So this will be the R0. Similarly, 4 pole Z1, Z1 is also inside. R1 will be limit Z tend to Z1, phi Z by psi dash Z, limit Z tend to Z1, 1 upon 4 Z cube. So that also will be 1 upon 4 Z1 to the power minus 3. So Z1 is how much? E to the power I 3 pi by 4. So 3 3 is 9. Okay. So it will become 1 by 4 e to the power minus 9 pi I by 4. So this is the answer. So integral will be 2 pi I, because both the poles are inside the contour. So we are using 2 pi I, or above the real axis. Above the real axis always take 2 pi I into 1 by 4 is common. R1 is e to the power minus 3 pi I by 4 and plus e to the power minus 9 pi I by 4. This is the answer. Here you can take common also. Okay. And you can check this 3 pi by 4. It comes in third quadrant. Fourth pi by 4, it comes in fourth quadrant. Or simply you can use the value 3 pi I by 4. Just I have taken here for simplicity. You can, the answer can be asked, option can be in this form also, or you can utilize the value, because value also I have already found. 2 pi I 1 by 4, you can use e to the power minus 3 pi I by 4. That will be minus 1 by root 2 minus I 1 by root 2. And this will be, because this is a third quadrant. Remember, value will be like pi by 4 only. Just you have to check, because this is for cos. Cos is also minus, sine is also minus in third quadrant. And this is a fourth quadrant. The value will be like pi by 4 only. So just in fourth quadrant, only cos is plus. So cos is plus, that will be 1 by root 2. Sine is minus, that will be 1 by. Now you can simplify it. So this to this cancel. It is minus 2 by root 2. It means it is root 2 only, and root 2 I. I into I will be I square. I square already minus is there, that will become plus. So you can write it. So from here, if you see pi I by 2 into, and from here you will see minus of 2I by root 2. This 2 to 2 cancel. So I to I will become I square is minus, 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 plus. So pi by root 2. Okay. So this is the answer. So integral minus infinity to infinity dx by 1 plus x to the power 4 will be equal to pi by root 2. Note down this. So this was a lengthy problem, but if you solve it, then it will give you a very good insight.
Done, sir.
Done. Okay. Okay, so this is the question. So for this also your contour is same. Okay, so यहाँ पे suitable fz will be 1 upon 1 plus z square whole square. So you can say that this is 1 upon 1 minus iz whole square into 1 plus iz whole square. So two poles are there, iz and minus iz. Poles. Sorry. You take I with this because z I want clear na. Z always should be clear. So that's why I cannot take it like this. Z always should be having coefficient 1. So I can write it z plus I whole square, z minus I whole square. So poles z equal to I and z equal to minus I are of order 2. These poles are of order 2. So what you can do, and z equal to I is where? It is here. Z equal to minus I is here. So this is outside. So we will leave it. Only this one we will consider. So residue at z equal to I pole. So that will be residue will be limit z tending to I 1 upon factorial n minus 1. 2 minus 1 because order is 2 na here. 2 minus 1 factorial into d by dz because it is d n minus 1 dz n minus 1. So it will be d by dz of z minus I whole square into fz. Fz is 1 upon z plus I whole square, z minus I whole square. Z minus I whole square will be cancelled. So only this much is left. Here you put z equal to I. So it will be I plus I 2I. 2I whole square. 2I whole square means 4 minus 4. So residue will be differentiation you have to do first, no? Then you have to put the value. So it will be minus 2. It will be limit z tend to I. This value will be 1. D by dz of z plus I to the power minus 2. So answer will be minus 2 z plus I to the power minus 3, and limit is your z equal to I. So minus 2 divided by 2I to the power 3 means 8 I cube. 8 I cube. So from that I will be left and minus minus will become plus. So answer is 1 upon 4I. So this is your residue. So I will be 2 pi I into residue is 1 upon 4I. So answer will be pi by 2. Note down this. Done?
Yes, sir.
Okay. One more question is there. You can do that, but I will give you a hint. Fourier integration. Cos Sx divided by x square plus k square. This is like this. Here s is greater than 1, k is greater than 0. Means both are positive value. S and k both are positive value. So this is the question. So first of all, we can convert it. I told you if in numerator cos x or sin x is there, you can convert. It is real part of e to the power I sx divided by x square plus k square. Okay. So then this will be equal to real part of 2 pi I into residue. This much only you have to see. Or summation of residue if more residue are there. Like this you can convert. Just find out the residue suitable. So here suitable fz will be directly you can write. Just you say see this much only now. E to the power I sz divided by z square plus k square. This z square plus k square I can convert in terms of pole like this, because when you put z square equals to k square, z will be plus minus ik. So pole it will be converted to z plus ik into z minus ik. This will be your denominator, and two poles are there, z equal to ik, z equal to minus ik. Now you have to check, because this is your contour. K, let it be how much bigger, no problem. This will be always upper than that, and it will be always inside that. I already told you. Ik will be there, minus ik will be there. So it is above the real axis, this one, and this is outside or below the real axis. So it will not be considered. Only for this you have to find out. Okay. For pole z equal to ik, find the residue. So residue you can find out now, because it is a simple pole. So limit z tending to ik, z minus ik into e to the power isz divided by z plus ik into z minus ik. This will be cancelled. Now you can put the value of ik here, then you will find the residue, and then you can put in this formula. You will get the answer. Okay. Answer you will match. The answer should be pi e to the power minus sk divided by k. This should be the answer. Note down it. You can complete it. Done?
That's a
Okay, suppose this type of integral is there. So what will be value of this? Tell me.
It should be 0, sir.
Yes, because these are odd function. If for the full integration odd function is there, this is also odd function. So then answer always will be 0. Okay, you can take it like this. Directly you can take. And one more thing I will tell. These are the homework for you. And it will give you the practice also. Number 1. Minus infinity to infinity. X sin x by x square minus sigma square dx. Sigma is the real value which is greater than 0. This is one question. Number 2. Number 3. Here for this you can get the poles and you can write this in terms of multiplication of that, because x square plus 1 you will write x plus I and x minus I. Similarly from here whatever the poles are there, x minus alpha, x minus beta, in that term you can write, then it will become fz. And one more question is there. So these 3 questions you solve. Answer I will give. For this answer is pi by 10. For this answer is minus pi root 3 by 6. And for this pi cos omega, pi cos sigma. Okay, so these are the answers. Note down.
Sir,
Yes,
third problem. Is it 3 minus x cube or 8 minus x cube?
8 minus x cube. I will tell you to get the pole now. First of all, the fz will be z upon 8 minus z cube. Then to get the pole, you will put denominator equal to 0. Is 8 minus z cube equal to 0. So z cube will be 8. Okay, but you can do it 8 into 1. And 1 we can write 8 into e to the power I 2 n pi. That will be the z cube. So z will be how much? 2, because you have to take 1 by 3 power. So 8 1 by 3 power is 2 into e to the power I 2 n pi by 3. So from here put, because here 3 are the roots, so 3 poles will be there. Put n equal to 0 1 2 and then find 3 poles. And then check which one is inside, which one is on the real axis, which one is above the real axis, and which one is below the real axis. Okay, and for such type of problem you can use to find out the residue phi z by psi z method. Okay, solve these 3 questions and send to me on WhatsApp. Okay, this is all for today.
Thank you.
Okay, welcome.